All right, so now we started to talk about those percentages that I was saying with the salt and sugar, or with the sugar and the water. So now we're looking at a saltwater solution. They look the same, right? This saltwater solution, when I'm looking at the beaker, they both just look like beakers of water. So now I have to look at numbers inside of it, and I have to do a little bit of math. Inside these beakers, my percentage has to add up to 100, right? It needs to add up. So I'm telling you in the directions up here, each beaker contains a salt water solution. That means the only things in it are salt and water. There's no sugar, there's no Kool-Aid, there's no chocolate syrup, just salt, just water. So if beaker A contains a salt water solution, and I'm telling you it is 70% water, this question says, what is the concentration of salt? Your whole concentration has to add to 100. So it's going to be 30% salt in beaker A, because 70 plus 30 is 100. Beaker B, same idea. It needs to add to 100. So if I'm telling you there's 80% water in beaker B, how much salt is there? It has to be 20% salt. We're going to use these kind of numbers and we're going to combine it with our understanding of cell membranes to see how liquids are going to move across a membrane. So, other questions, other follow-up questions for this could be, which solution has a higher concentration of salt? 30 is higher than 20. It's beaker A. We could say which solution is, or which beaker is saltier? A, because there's more salt, right? So we can reword the question, but you're always going to want to come back to those numbers. Your total percentage has to add to 100. So again, this is just the idea of concentration, mixing the solute, the salt, with the solvent, water, to make a solution, combination of the two. Once you understand this, we're going to reintroduce the idea of cell membranes and how the concentration affects the movement of the molecules.